we're going to start talking about polynomial multiplication. This will match up with the notebook pages 8 through 8B. So hopefully you've already downloaded the note pages and can follow along. If we remember from the last lesson, we can remember the words polynomial, binomial, and trinomial. We've already done polynomial multiplication of monomials and binomials. This is as simple as 4 times x plus 3. When we use our distributive method to get 4x plus 12, we're doing polynomial multiplication. The more generic example is simply x times x plus some value. In this case, I'll use 3. We're once again distributing, and x times x becomes x squared, x times 3 becomes 3x. So we've been doing this type of monomial times binomial for quite a while. Let's look at binomial multiplication. In this case, we'll use the example from the notes of x plus 5 times x plus 2. As noted in the problem, we're going to use the distributive method to solve this problem. But the acronym we'll use to remember it is FOIL, which stands for first, outer, inner, and last. This simply refers to the order in which you multiply everything together. Our goal is to multiply all times all. Everything in our sets of parentheses should be multiplied together. First simply refers to multiplying the first things in each set of parentheses. Outer refers to the outermost values in the parentheses. Inner refers to the inside set of parentheses. And last refers to the last values in the parentheses. When we work this out, we get that x times x gives us x squared, x times 2 gives us 2x, 5 times x gives us 5x, and 5 times 2 gives us 10. If we continue to combine our like terms of positive 2x and positive 5x, we get a final answer of x squared plus 7x plus 10. Let's do one more quick example. X plus 4 times x minus 3. Again, we'll follow our multiplication pattern. First, outer, inner, and last. Remember, FOIL is just an acronym that represents the distributive property. So, x times x gives us x squared. X times negative 3 gives us negative 3x. 4 times x gives us positive 4x. And 4 times negative 3 gives us negative 12. Again, we can locate our like terms and combine them for a final answer of x squared plus x minus 12. I do want to look at one special case and make sure that you remember something. When given a problem such as this, the most common answer that people automatically jump to is x squared plus 2 squared. But this is, unfortunately, wrong. The key to this is to remember what squaring actually means. Squaring means that you're multiplying the value of x plus 2 times itself. When you come back and FOIL the values, we get a result of x squared plus 2x plus 2x plus 4. In this case, if we had gone with our initial guess, we would have missed out on these two x's inside. So our final answer should have been x squared plus 4x plus 4. One of the most important things you can take away from the lesson is simply this, that any value a plus any value b squared is not equal to a squared plus b squared. By far the most important part of this lesson is this line right here. I want you to remember that squaring a set of parentheses will result in more than just two values as the result. Let's look at a second method to do polynomial multiplication of two binomials. We'll use the same example, x plus 5 times x plus 2. This is called the box method. While the previous distributive method mainly relied upon memorization of a pattern that you multiply, the box method is a visual representation of that same pattern. To do the box method, we're going to start by drawing a box. The box represents the answer to our problem. Specifically, it represents the area of our problem. We recall that area is equal to length times width. In our problem, we have two values being multiplied together, x plus 5 times x plus 2. We can simply use these as our length and width to create a new area plot using this box. Our first value we'll just call the length. If it represents the length from here to here, we can break that down into a positive x and a positive 5. This distance represents the distance x. This distance represents the distance 5. So our total length is our x plus 5 value. Now we'll say that x plus 2 represents our width. Since we already have our length going across, our width will go down. Once again, we can split it into positive x and positive 2. The distance here represented by x, and this distance here represented by positive 2. So our total width is x plus 2. Now we simply need to find the area of each of these four inner squares, or rectangles. Since the area of a rectangle is still length times width, we simply need to multiply our length times our width for each of these inner shapes. The upper left box is x times x, which gives us x squared. The upper right box is 5 times x, which gives us positive 5x. The lower left gives us positive 2x, and the lower right gives us positive 10. To find our final answer, we simply need to combine all four of these areas into a single problem. So we'll start pulling them out. X squared, positive 5x, positive 2x, and positive 10. As we look at this problem, we identify that 5x and 2x are like terms and can be combined. When we do combine them, we get a final answer of x squared plus 7x plus 10. This is the same answer we found with the distributive method and the FOIL acronym in the previous page, but it's a different way of looking at the problem. Let's look at another. Our problem now will be 3x minus 5 times x minus 2. Once again, we'll start with a box. Since we have two binomials, or problems with two terms each, we know that we'll have our giant box split into two columns and two rows. 3x minus 5 can be broken down into 3x and negative 5. X minus 2 can be broken down into x and negative 2. When we start multiplying our lengths times widths, we get 3x squared, negative 5x, negative 6x, and negative 10. Once again, we can just pull all of these areas out and combine them into 3x squared minus 5x minus 6x minus 10. Now, if you've been paying real close attention, you'll notice that I made a mistake. Hopefully you caught it. If not, we'll correct it now. Negative 5 times negative 2 should have given me positive 10. So we'll fix that here. As we go through and combine our like terms, we can identify that negative 5x and negative 6x becomes negative 11x. All the rest of our values simply move down, and our final answer is 3x squared minus 11x plus 10. Now let's look at the final type of multiplication we're interested in, a binomial times a trinomial. In this case, our binomial is x plus 2, and our trinomial is x squared minus 2x plus 4. There are two methods to find the answer to these problems: the distributive FOIL method or the box method. So we'll run through both of them very quickly. For the distributive method or FOIL method, we start by simply examining our problem. In the original FOIL method, we multiplied the binomial values by another set of binomial values. But in this case, we need to deal with the trinomial, or the extra value. Since our goal, as stated back on a previous page, was to multiply everything by everything, or all by all, we now need to consider multiplying x times x squared, x times negative 2x, and x times 4. To continue multiplying all by all, we'll also have to multiply 2 times x squared, 2 times negative 2x, and finally 2 times positive 4. When we complete this multiplication, here's what we get. X times x squared gives us x cubed. X times negative 2x gives us negative 2x squared. X times positive 4 gives us positive 4x. 2 times x squared will give us 2x squared. 2 times negative 2x gives us negative 4x. And 2 times 4 gives us positive 8. As we look to combine like terms, we can identify that negative 2x squared and positive 2x squared are like terms, as are 4x and negative 4x. When we combine our like terms, we get a final answer of x cubed plus 8. In this case, all of our inside values sum to 0 or canceled out. This will not always be the case, as you could easily end up with a problem that looked like this, where it has an x cubed term, an x squared term, and an x term. In this case, we lost these two terms when they all canceled out. Now let's look at the box method. We'll start with the same problem. As we build our box, we notice that we have a binomial times a trinomial. So we'll be splitting our box into 2 columns and 3 rows. Our binomial will be on top, positive x, positive 2, and our trinomial will be down the left side, positive x squared, negative 2x, and positive 4. As we complete our multiplication, you'll notice that we are doing the same math problems as we did here on this problem. We're just reorganizing them. X times x squared gives us x cubed. X times negative 2x gives us negative 2x squared. And x times 4 gives us positive 4x. 2 times x squared gives us 2x squared. 2 times negative 2x gives us negative 4x. And 2 times 4 gives us positive 8. Just like in the previous problem, you'll notice that 2x squared and negative 2x squared will cancel each other out, and 4x and negative 4x will cancel each other out. Once again, this leaves just x to the third plus 8 for our final answer. Being able to multiply all of these math problems is going to be incredibly important as we move throughout the rest of the year. So hopefully this has helped you understand what your notes on page 7 and 8 all really mean.